Hi guys, welcome back to our YouTube channel. Today we are going to learn about Introduction to Trigonometry for Class 10 CBSC Mathematics. So this is the reason why we took this video. So let's begin the class. So what do you see in this picture? You see a guy standing down the river and seeing a top of the tower. Okay, and seeing the top of the tower. And in here you could see the same thing. And this is the angle in which he sees the top of the tower. Okay. So when a guy sees from this angle, okay, from this angle, this is his opposite side, okay, and this is his adjacent side, and this is normally the hypotenuse. Similarly, when that guy sees from C, angle C, this is his opposite side and this is his adjacent side, and normally this is the hypotenuse. Are you clear with this? Now, sine of angle A equals just, it's very simple, sine of angle A equals opposite by hypotenuse. That's it. Where for sine A, it is BC by AB. Okay. Then for cos A is adjacent by hypotenuse. That is, for cos A is adjacent by hypotenuse. And for tan is sine by cos. Okay, tan equals sine by cos. So that this is opposite by adjacent. Like for angle tan A, it is BC by AB. Okay, for cosecant of angle A equals 1 by sine, so that it is hypotenuse by opposite, just the reciprocal of sine. Cosecant is the just reciprocal of sine, and secant, similarly, it is just the reciprocal of cos, and cot is the reciprocal of tan. So these things will be ulta in these things. Okay, next, for example 1, given tan A equals 4 by 3, find the other trigonometric ratios of angle A. So this is the angle A. We need to find sine A, cos A, cosecant A, cot A, and secant A. There is tan A. So in this thing, you need to use Pythagoras theorem to find AC. AB square plus BC square equals AC square. That is the Pythagoras theorem. So 3k whole square plus 4k whole square equals AC square. And they have found that AC equals 5k. And for sine A equals opposite by hypotenuse. That is BC by AC. And that equals 4 by 5. Okay. And for cos, it is adjacent by hypotenuse. That is AB by AC. That equals 3k by 5, kk cancels, and this is 3 by 5. So cot A equals reciprocal of tan. Cot is reciprocal of tan. So tan equals 3 by 4, 4 by 3, right? So if tan A equals 4 by 3, reciprocal of tan A equals 3 by 4. Cosecant A is the reciprocal of sine A. So cosecant A, we have found that sine A equals 4 by 5. So cosecant A, it will be 5 by 4. Secant A is the reciprocal of cos A. So that will be 3 by 5 will be 5 by 3. So we have found the answer, right? So we are going to see similar questions. This is from 8.1, okay? 8.1 exercise. So if sine A equals 3 by 4, calculate cos A and tan A. So in this, we need to draw a small triangle, right angle triangle, okay? This is angle A, okay? Angle A, B, and angle C. So angle A, if you see sine A is opposite by hypotenuse. So opposite is 3. So CB is 3 and hypotenuse is 4. You need to find AB. So you need to use Pythagoras theorem, and we have found that root 7 is AB. Okay. So now from this angle, what is cos A? Cos A is adjacent by hypotenuse. So adjacent is root 7 and hypotenuse is root 4. So for cos A is root 7 by 4. Okay. For tan A is sine by cos, that is 3 by 4 by root 7 by 4. In this case, both the denominators 4 will be cancelled and the answer will be 3 by root 7. Okay, let's move on. So this is also a similar question. 15 cot A equals 8. Find sine A and secant A. So we are going to draw again a small triangle. This is A, B, and C. So cot A, we have seen that cot A is adjacent by opposite, right? Adjacent by opposite. So this is the angle A. So which is the adjacent? AB is the adjacent, right? So 15 by 17. And for secant A is reciprocal of cos A. So that is hypotenuse by adjacent. So hypotenuse is 17 and adjacent is 8. So 17 by 8 is the answer. Did you get it? Now next, example 3. We are going to go to new example. So consider triangle ABC, right angled at C. So here it is right angled, in which AB equals 29 units. AB is the hypotenuse. BC is 21 units. Okay. According to this theta angle, this is the adjacent, this is the opposite, this is the adjacent, this is the opposite, and this is the hypotenuse. So we need to determine the cos square theta plus sin square theta and cos square theta minus sin square theta. So, in the chapter 2, we will be learning about another main formulas. So the first formula is sin square theta plus cos square theta. So sin square theta plus cos square theta equals 1. That formula you will be using in part 2. So that's the thing we are going to use here. The answer will be 1. No need to do big calculations. Just use the formulas. And for cos square theta and sin square, cos square theta minus sin square theta. For cos theta equals adjacent by hypotenuse, that is 21 by 29. And for sin theta, it is opposite by hypotenuse, that is 20 by 29. So we need to find AC by Pythagoras theorem. So here, cos theta we have found the 21 by 29. So for cos square theta, it will be 21 by 29 whole square. And for sin square theta, that will be 20 by 29 whole square. When you do this, you will get an equation like this, and you need to solve, and you get 41 by 841. Okay. So next, example 4. In right triangle, ABC is a right triangle. Right angled at B. If tan A equals 1, they are using angle A. So tan A equals 1. Then verify that 2 sin A cos A equals 1. So tan A is sine by cos, right? So sine by cos. Sine is, don't go like that side. You can use that tan equals opposite by adjacent. So if opposite is 1, then adjacent will also be 1. Yeah, right. You need to use Pythagoras theorem in this to find AC. AB square plus BC square equals AC square. So AB square is 1, BC square is 1. So AC square will be root 2. Okay, so now sine A, from this angle, sine A is opposite by hypotenuse, that is 1 by root 2. And for cos A is also like from angle A, cos A is adjacent by hypotenuse, that is into 1 by root 2. So then into 2, they have given in the equation itself, into 2 equals 1. Okay, equals. So first, root 2 into root 2 equals 2, right? 2 by 1 into 2. 2 cancels and the answer is 1. Hence proved. Okay. Next, example 5. In triangle OPQ. OPQ is a triangle, right angled at P. OP is 7 centimeter. This is 7 centimeter. OQ minus PQ equals 1 centimeter. OQ minus PQ equals 1 centimeter. Okay. Determine the values of sine Q and cos Q. So first we need to find OQ and PQ. Okay. For that we are going to use Pythagoras theorem. OQ square equals QP square plus PO square. So this is the Pythagoras theorem. So they have given that OQ equals PQ, OQ minus PQ equals 1. So instead of OQ square, we are going to substitute that OQ equals 1 plus PQ. We are going to take minus PQ to RHS and add as plus PQ. Okay, that's why they are given as 1 plus PQ whole square. So instead of OQ square, that is 1 plus PQ whole square. 1 plus PQ whole square equals OP square plus PQ square. A plus B whole square. In this thing, you need to use A plus B whole square formula. A square plus 2AB plus B square. So now, from both LHS and RHS, PQ square will be cancelled. Okay. Then 1 plus 2PQ equals OP square. They have given that OP equals 7. So instead of OP square, substitute 7 square. 7 square is 49. 1 plus 2 PQ equals 49. So PQ equals 49 minus 1. 1 will be going to RHS. 49 minus 1. 2 PQ equals 48 and PQ equals 24. We have found that PQ equals 24. Okay. So now substitute PQ in this equation to find OQ, and they have found that OQ equals 25 centimeter, hypotenuse equals 25 centimeter. So as usual, sine Q from this angle opposite by hypotenuse 7 by 25 found, and cos Q equals adjacent by hypotenuse, adjacent is 24 and hypotenuse is 25, is 24 by 25, and we got the answer. So now we are going to enter into the 8.1 question. Question number 1. In triangle ABC, right angles at B, AB equals 24, BC equals 7. Determine sin A cos A, sin C cos C. So first draw a right angle triangle. Okay. And this is right angled at where? At B. So let this be A, B, and this be C. Okay. AB equals 24 centimeter. This is 24. And BC equals 7 centimeter. This is 7. And we need to find hypotenuse. For that, you are going to use Pythagoras theorem, and we found that AC equals 25 centimeter. Okay. So sin A. Sin A means from this angle opposite by hypotenuse, that is 7 by 25, cos A equals adjacent by hypotenuse, that equals 24 by 25. You can see that in the next slide. 7 by 25 for sin A and 24 by 25 for cos A. And for sine C from this angle, sine C equals opposite by hypotenuse, 24 by 25. And cos C equals adjacent by hypotenuse, that equals 7 by 25. That you can see in the next page. Yeah, here. Okay, these things we found it. Next, we are going to go to the next question. In figure 8.13, find tan P minus cot R. Before this, you need to find QR, the other side. For that, you need to use Pythagoras theorem. You found that this is 5. This is 5 centimeter, right? Okay, this is 5 centimeter. Okay, tan P, that is the angle is here. Tan P equals, tan means opposite by adjacent. So opposite is 5, right? Opposite is 5 by adjacent 12. Okay, opposite by adjacent 5 by 12, and then minus cot R from this angle, adjacent by opposite. Adjacent is 12, opposite is 5. Sorry. Adjacent is 5 and opposite is 12. Okay, adjacent is 5 and opposite is 12. This is not thing. When you minus these, you would get 0. 0 is the answer. Yeah, in the next page you got that. So moving on to the next question. Given secant theta equals 13 by 12, calculate all trigonometric ratios. You saw these questions in the first part, right? The first slide. Like, this is a right angled triangle. A, B, and C. Let this be theta. Okay. Secant theta equals hypotenuse by adjacent. So hypotenuse is 13 and adjacent is 12. So 13, 12. And the other side will be 5. We have found that 5. Okay. When you use Pythagoras theorem, you get this as 5. And now you need to find sine, cos, tan, cosecant, cot by using the formulas. So for sine theta equals opposite by hypotenuse, that is 5 by 13, and for cos, adjacent by hypotenuse, that is 12 by 13, and for tan, that is opposite by adjacent, so it is 5 by 12. Cosecant equals hypotenuse by opposite, that is 13 by 5, and you found the secant. And cot is adjacent by opposite, that is 12 by 5. These are the answers. Next, if angle A and angle B are acute angles such that cos A equals cos B, then show that angle A equals angle B. So let us assume a triangle ABC, okay? A, B, C, A, B, and C. In this, CD, no, CD, not CD. AB is like perpendicular to BC. This is B, not D. Printing mistake. Okay. Given that angle A and angle B are acute angles, they have given that angle A is acute. You don't use this. You use C. Angle A and angle C are acute angles. So cos A and no, this is a wrong question. This is not the right answer. Next. If cot theta equals 7 by 8, evaluate. So let us assume a triangle ABC in which angle B is the 90 degrees and angle C is the theta. So ABC, angle B, angle C as theta, and angle A. Okay. Now, so cot theta equals adjacent by opposite. So adjacent is 7 and opposite is 8. And we need to find the hypotenuse by using Pythagoras theorem, and that is root 113. Okay. So sine theta equals opposite by hypotenuse, that is 8 by root 113. So 1 plus 8 by root 113 into 1 minus 8 plus 8 by root 113 by 1 plus cos theta. Cos theta means like adjacent by hypotenuse, that is 7 by root 113. So 1 plus 7 by root 113 into 1 minus 7 by root 113. Okay, you get the answer. Like in next slide. Yeah, you got it. This one, first one you got. And second one, cot square theta, cot square, cot is adjacent by opposite. They have given that 7 by 8 is cot. So just square it. 49 by 64 is the answer. Yeah, you got this. 49 by 64 is the answer. Moving on to the next question. 8. If 3 cot A equals 4, check whether 1 minus tan square A by 1 plus tan square A equals cos square A minus sin square A or not. So this is like proving LHS and RHS like thing. So first is you need to take a triangle ABC. A, B, and this is C. So yeah, we know that cot function is reciprocal of tan, that is adjacent by opposite. So take 3 to RHS, that is cot A will be 4 by 3, okay? So 4 is the adjacent side. From A, 4 is the adjacent side. And 3 is the opposite side. So BC is 3, AB is 4, and we need to find AC. Hypotenuse is 5K. We found 5K. By using Pythagoras theorem, we found it 5. So next, just you just need to evaluate this thing by using these numbers. So tan square A, tan equals reciprocal of cot A. So tan equals opposite by adjacent. Opposite of A is 3 by 4. So 3 by 4, 1 minute. 1 minus 3 by 4 whole square by 1 plus 3 by 4 whole square. Wait, this is 1 plus 3 by 4 whole square equals cos square. What is cos square? Cos A is adjacent by hypotenuse, that is 4 by 5 whole square minus sine. Opposite by hypotenuse 3 by 5 whole square. Then when you substitute like that, the LHS should be equal to RHS. The LHS is 7 by 25 and RHS is 7 by 25. Therefore, hence, it is proved. Okay? So next, in triangle ABC, right angled at B, if tan A equals 1 by root 3, find the value of. So similar question like 8. So this is triangle ABC. A, B, and C. Okay? Tan A is opposite by adjacent. This is from angle A. Opposite is 1 and adjacent is root 3. By using this, you need to find the AC using Pythagoras theorem, that is AZ equals 2. So this is 2. Okay. Now sin A plus cos A plus cos A sin A. Sin A cos A, sin A cos C plus cos A sin C. So sin A is opposite by hypotenuse, that is 1 by 2. Okay. And cos C, from this angle cos C is adjacent by hypotenuse into 1 by 2. Okay. Then plus cos A, cos A equals adjacent by hypotenuse, that is root 3 by 2 into sin C. Sin C is opposite by hypotenuse, that is root 3 by 2. That equals 1 by 4 plus 3 by 4, that equals 4 by 4 equals 1. 1 is the answer. Yeah, 1 is the answer. See? You substitute this, you get 1 as the answer. Similarly, when you substitute these things in the similar manner, you get the answer as 0 for second subdivision. Okay, we are up to the class. We are going to finish. In triangle PQR, right angled at Q, PR plus QR equals 25 centimeter and PQ equals 5 centimeter. Determine the value of sin P, cos P and tan P. So just draw a triangle, that is right angle triangle. Okay. They have given that right angled at Q. So here is Q, this is P, and this is R. Okay. Okay. So they have given that PR plus QR equals 25. That is PR plus QR equals 25 and PQ equals 5 centimeter. So you saw this question in here. That was an example. Yeah. You need to do the similar way like this to get the answer. For that you, so that you get the next two sides, you need to use this thing. Okay. And you get the other sides. The first side is QR. QR is 12 centimeter. They have found that 12 centimeter. PQ is 5 centimeter. And PR is 13 centimeter. They have found like this. And now we need to find sin P, cos P, tan P. So P, this side. So sin is opposite by hypotenuse. So 12 by 13. Okay. Cos P, adjacent by hypotenuse. That is 5 by 13. Got it. And tan P is opposite by adjacent, that is 12 by 5, and we got the answer. State whether the following are true or false. Justify your answers. The value of tan A is always less than 1. Is that true? No, it's false. The value of tan A is always not less than 1. It's more than 1, right? Next. Secant A equals 12 by 5 for some value of angle A. Answer is true. Because a triangle is possible at it will follow the Pythagoras theorem only, where K is a positive real number. By Pythagoras theorem, we get mc square plus mn square plus nc square. mc square equals mn square plus nc square. So when you substitute like that, you would get 119k square. Okay, so this is true. Cos A is abbreviation used for the cosecant of angle A. No. Abbreviation used for cosecant of angle M is cosec M. Cos M is the abbreviation used for cosine of angle M. Cos is different, cosecant is different. Okay. Cot is product of cot and A. Cot is the product of cot and A. False. No. Cot M is not the product of cot, and M, it is the cotangent of angle M. Okay. Sin theta equals 4/3 for some angle theta. Sin theta equals 4/3 for some angle theta. No, it's false. It's ultimately false. Okay. So subscribe, like and share, and give a thumbs up if you liked it. Doubts can be commented in the chat box. Thanks for watching, and the continuation will be given in the part 2. Be good, do good from Brahma Kumari. Thank you guys. Bye.